We thought we knew what to expect. Another cosmic nomad, another frozen wanderer just passing through our corner of the galaxy, unremarkable except for its origin beyond our solar system. Just the third interstellar visitor we've ever detected. Notable, but not revolutionary. Until now, because 3I/Atlas isn't behaving like anything we've seen before. It isn't following the rules. It's breaking them, one by one, leaving astronomers worldwide in a state of quiet bewilderment. And it all started with a spectral fingerprint that shouldn't exist. The Very Large Telescope in Chile captured it first. A chemical signature that made scientists double-check their instruments, then triple-check their calculations. Not because the signal was faint, but because it was impossible, pure nickel gas, floating around 3I/Atlas like an elemental halo. Nickel alone, without iron. And that's where the mystery begins. Because in the cosmic crucible, nickel and iron are inseparable twins, born together in stellar furnaces, scattered together in supernovae, traveling together through the void. In every asteroid, every meteorite, every comet ever studied, where one appears the other follows. Until 3I/Atlas. It's like finding a shadow without an object, says Dr. Elena Vasquez of the European Southern Observatory. These elements don't separate naturally. They can't separate naturally. Not according to everything we know about stellar nucleosynthesis. But separate they have. The signal is clear, unmistakable, persistent. Week after week, the telescope keeps detecting nickel, sharp, defined, isolated, with no trace of iron whatsoever. It's not just unexpected, it's unprecedented. And it might be just the beginning of what makes 3I/Atlas so strange. Look at its trajectory, retrograde, moving against the natural flow of our solar system, like a salmon swimming upstream. Not impossible for a natural object, but statistically rare, suspiciously rare. Look at its path, not just passing through our solar system, but following a trajectory that will bring it remarkably close to multiple inner planets. Too close, some say, to be mere coincidence. Too precise to be random chance. Look at its emissions, high levels of carbon dioxide, a developing coma unlike typical comets, and now this isolated nickel signature that defies explanation. One anomaly could be dismissed as measurement error. Two might be coincidence. But 3, 4, 5 unusual characteristics in the same object. That's when scientists start questioning their assumptions. That's when the whispers start. We're not jumping to conclusions, insists Dr. Hiroshi Nakamura of the Tokyo Astronomical Observatory. But we're running out of natural explanations that fit all the data points. At some point, we have to consider alternatives. Alternatives, that's the word scientists use when they're approaching territory that makes them uncomfortable, when they're forced to consider possibilities that lie outside the boundaries of conventional thinking. Could 3I/Atlas be something more than a natural interstellar object? A fragment, perhaps, of something engineered, a piece of ancient technology, worn down by eons of travel between the stars. Most astronomers still reject these possibilities outright, not because they're impossible, but because extraordinary claims require extraordinary evidence. And right now, the evidence is intriguing, but incomplete. Science doesn't work by jumping to the most exciting explanation, reminds Dr. Sarah Collins of the Planetary Science Institute. It works by methodically testing hypotheses against data, by ruling out the ordinary before considering the extraordinary. And there are ordinary explanations still on the table. Some suggest we're simply observing the early stages of activation as 3I/Atlas approaches the Sun. Different compounds vaporize at different temperatures. Nickel carbonyl molecules break down more easily than iron-bearing minerals. Perhaps the iron is still locked in the object's core, waiting for higher temperatures to release it. What we're seeing could be phase 1 of a perfectly natural process, explains Dr. James Chen. Give it time. As it approaches perihelion, we'll likely see iron emerge as well. A reasonable hypothesis, testable, falsifiable. In the coming months, as 3I/Atlas continues its journey sunward, temperatures will rise. If iron appears, the mystery diminishes, not completely, but significantly. But what if it doesn't? What if the nickel remains isolated, pure, deliberate? That's the question keeping astronomers awake at night, because it leads to other questions, bigger questions, questions that extend beyond chemistry and orbital mechanics. Questions about our place in the cosmos. about whether we've been alone all this time, or merely unobservant. The universe doesn't organize itself according to human expectations, notes theoretical physicist Dr. Wei Zhang. Sometimes the truth is simply strange, and sometimes strangeness is a doorway to discovery. Discovery, that's what drives science forward. Not confirmation of what we already believe, but revelation of what we never imagined. Not comfort, but disruption. And 3I/Atlas is nothing if not disruptive. Even those who reject any notion of artificiality admit that this object is teaching us something new. It's showing us gaps in our understanding, flaws in our models, assumptions we didn't realize we were making. Whether natural or not, 3I/Atlas is valuable precisely because it's anomalous, argues astrochemist Dr. Fatima Al-Farsi. It's forcing us to question our frameworks, to test the boundaries of our knowledge. That's how science advances, not by reinforcing what we know, but by challenging it. The challenge is substantial, because with each new observation, 3I/Atlas seems to defy more expectations. Recent data from radio telescopes reveal unusual emission patterns, not consistent with known cometary behavior, not easily explained by standard models of sublimation and outgassing. Infrared observations show temperature variations across the object's surface that don't match predictions for a rotating icy body exposed to solar radiation. And that nickel signature, it's not fading, it's intensifying as 3I/Atlas approaches the inner solar system, growing stronger, more defined, more anomalous with every passing week. We're watching something unprecedented unfold in real time, says Dr. Carlos Menendez of the Atacama Large Millimeter Array. Whatever 3I/Atlas is, whatever process is generating these observations, it's not in our textbooks. Not yet. Not yet. Those two words contain multitudes. They acknowledge both current ignorance and future understanding. They hold space for the unknown, while maintaining faith in our ability to eventually know it. But some are less patient. Some want answers now. And among them is Dr. Aver Lober, the Harvard astrophysicist who shook the scientific community when he suggested that Oumuamua, our first detected interstellar visitor, might be artificial. Now he's watching 3I/Atlas with keen interest. The combination of anomalies we're observing cannot be easily dismissed, Lober argues. The isolated nickel signature, the retrograde orbit, the precise trajectory, the unusual emissions, together they raise the probability of artificial origin significantly. How significantly? I would put it at about 6 out of 10, he says. Not certain, but well within the realm of serious scientific consideration. Most of his colleagues disagree, placing the probability much lower, but even they admit that 3I/Atlas has pushed them into unfamiliar territory, a zone where certainty dissolves and possibility expands. A zone where science meets imagination. Because that's the thing about staring into the cosmic unknown. It doesn't just challenge our knowledge, it challenges our conception of what knowledge can be. It forces us to consider not just what we don't know, but what we don't know we don't know. The history of astronomy is a history of humbling discoveries, reflects Dr. Vasquez. Copernicus showed us we're not at the center of the universe. Hubble showed us our galaxy is just one among billions. What might 3I/Atlas show us, if we're open to its message? Message. The word hangs in the air, loaded with implication, because what if that's exactly what this is? Not just an object, but a signal. Not just matter, but meaning. Not necessarily a deliberate message sent to us, perhaps not a message at all in the conventional sense, but a trace of something beyond our current understanding. A glimpse of processes or possibilities we haven't yet imagined. Even if 3I/Atlas is completely natural, says astrobiologist Dr. Michael Santos, it's communicating something profound that the universe is stranger, more diverse, more surprising than our models predict, and that in itself is worth listening to. Listening, that's what we're doing now, with every telescope pointed at this enigmatic visitor, with every spectrometer breaking down its light, with every radio dish scanning for signals. We're listening, not just with our instruments, but with our minds, with our imagination. And in that listening, something beautiful happens. We grow, we expand, we become more than we were before this strange object entered our solar system. Because that's the true power of the unknown. It doesn't just exist out there in the darkness, It exists within us, as curiosity, as wonder, as the drive to understand. 3. Is/us is strange, undeniably, persistently strange. It doesn't fit our models, it doesn't match our expectations, it doesn't follow our rules. Good. Because in that strangeness lies possibility, in that mystery lies discovery, in that uncertainty lies the future of our understanding. So we keep watching, we keep measuring, we keep debating, we keep learning, and maybe, just maybe, we keep hoping. Not necessarily for aliens or ancient technology or cosmic messages, but for something equally profound, the chance to be surprised, the opportunity to be wrong, the privilege of seeing the universe as it actually is, rather than as we thought it was. In the coming months, 3I/ATLS will continue its journey through our solar system. It will pass closer to the sun, experience more heat, reveal more of its nature. The nickel signature will either remain isolated, or iron will finally appear alongside it. Either way, we'll learn something. Either way, we'll grow in our understanding. Because sometimes, the greatest discoveries aren't what we find out there in the darkness. Sometimes, the greatest discoveries are the gaps in our knowledge, the flaws in our thinking, the spaces where mystery still thrives, despite our best efforts to eliminate it. The 3I/Atlas is behaving strangely, and we don't know why, not yet. But we're watching, we're listening, we're wondering, and in that watching, listening, and wondering, something profound is happening. We're becoming more than we were. One observation at a time, one question at a time, one mystery at a time, until finally, perhaps, we understand not just what 3I/ATLS is, but what it means, not just where it came from, but what it reveals about our place in the cosmos. Because in the end, that's what astronomy has always been about, not just observing distant objects, but seeing ourselves more clearly by the light of distant stars. And 3I/Atlas, strange as it is shining a light on something important, the beautiful, necessary incompleteness of human knowledge. The universe is not just what we know, it's also what we don't. It's the questions we haven't answered, the mysteries we haven't solved, the phenomena we haven't explained. It's 3I/Atlas, drifting through our solar system, leaving a trail of pure nickel where iron should be, following a path too precise to be random, emitting signals too strange to be familiar, challenging us, challenging us, challenging us, with the task of understanding. And even if we never fully grasp what 3I/Atlas is, even if it remains partly mysterious even after it has left our solar system behind, it will have accomplished something remarkable. It will have reminded us to look up with wonder, to question with courage, to imagine with rigor, to be, in other words, the best of what humans can be, curious, humble, alive to the mystery. And in a universe as vast and strange as ours, what more could we ask for?